Hello and welcome back everyone. I have an old bench that I use for setting up tooling for the lathes and mill. It has my big Aussie Vise attached and it's had some use. The plywood top has seen better days and needs to be replaced. However, I have an idea for upgrading to a more tool friendly surface. I also want to make a tooling stand for setting up tooling for the mill. G'day, I'm Steve-O and welcome to the Outback shed. The bench in question is an engine teardown bench. It's designed for just that purpose. It has an oil drain to one end that drains oils and other fluids into a capture drawer for later disposal. It's a great bench, but I'm not planning on rebuilding any engines. Well, not at this time anyway. As a base, I'm going to use a 19mm yellow tongue flooring panel. It is much stronger and stiffer than MDF and a lot denser. It's also resistant to moisture and other liquids. I'll remove the tongue and keep that for some use in the future. I'll put links to all the materials in the description. It's been a while since my last video, but there's been a lot going on. We've had a family member in intensive care for 6 weeks, but big shout out to Paul, who is now recovering well. Cheers mate, get well soon. After cutting it to size, I'll glue a cork edging around the sheet. While I appreciate that undertaking woodwork for a bench might not be the greatest interest to viewers on a machining channel, I will include this part of the build, as it's a useful support for the machining aspects of my hobby. It will also provide a descriptive for anyone who wishes to upgrade their tooling bench in the same way. If you want to watch only the machining aspects of this project, you can skip forward to 10 minutes 30 seconds and maybe come back later to this section. Some time ago, I visited the engine tool room in an aerospace company. It had a parquet timber floor in a herringbone design. Its purpose was to allow any item dropped on it to be recovered undamaged. The timber surface was softer than any tooling, and so the tools will bounce to avoid damage. The plywood has served this purpose for some time, but I want to replace it with cork as that will have other advantages. After trimming the edges with a knife and chisel, I'll run an orbital sander with an 80 grit sanding disc over the face to even out the edges. Cork tiles come in packs of 6 and they're 305 by 305 by 6mm thick. I got them from a local hardware store and they're about $20 a pack. I'll stick them to the board with contact adhesive. I'm applying the adhesive to the backing board only and not the tiles. Applying to both contact areas makes the final moving of the tiles into place difficult as the adhesive is drier and the parts just don't slide. By applying it to one face only, I can slide the tiles around and move them into the position I want before the adhesive sets. Some weights hold the tiles in place and stop the edges curling while the adhesive sets. I'll trim the final row in the bandsaw. The sizes have worked out perfectly. I get the 3 pieces I need out of the one tile. Then moving the tiles around helps to ensure no bubbles of air in the lift in the adhesive, and the tiles are positioned to provide a few millimetres of overhang for later trimming. After trimming the excess with an X-Acto knife, I'll clean the top up with an 80 grit sanding disc. Now I'll run a flush trim router bit around all edges with a laminate trimmer to even the top. Cork is a soft material and the router bits tend to grab, so I need to be gentle as I go. A 45-degree bevel finishes the edges and makes it less prone to damage. I'll seal the top with a clear semi-gloss water-based finish and I'll apply 5 coats. That should work out just fine. I couldn't have asked for the top to fit any better. It's a perfect fit on the bench and around the vise. Setting a face mill cutting edge down ensures it can't roll around on the bench, and the cutting inserts are protected by the soft cork surface. They are now not prone to being damaged by other items on the bench or being a hazard for cuts and scratches. Now for the tool setting stand. I obtained a piece of hot rolled mild steel 250 by 110 by 16mm thick for the top plate. As it's hot rolled, it will warp somewhat during machining, but other than the hole for the holder, the dimensions aren't critical, so as long as the surface is consistent, it will be fine. I'm using the 130mm Coromat face mill I refurbished in a previous video. I'm running it at 650 RPM. I would prefer a fly cutter, but my small fly cutters are too small and the big one I made is too big, so this face mill will just have to do. A 2mm chamfer around the edges finishes the face. The hole for the holder is 70mm in diameter. As I only have a 45mm annular cutter, I'll bring the hole to size with a 50mm boring head. I'm just using a manual feed with the hand lever. This is the first time I've used this boring head, and I'm getting the impression that it's just a little light for this job. Now I'll drill the counterbore holes for 5 8mm socket head cap screws to mount the top plate to the bottom plate. Now for some turning. I have a piece of 100mm diameter 4140 which I'll use for the holder. It's not the best choice of material. 1045 would have been a better choice, but that's all I have. Although in hindsight 1045 would have been the best choice. I should have purchased a piece for this project. The steel is bird's nesting and it's producing an ugly swarf. I recently replaced the coolant with Hangserfers 5080 and that seems to be making a good improvement. I've been getting very good results with these carbide inserts, but they do seem to be struggling a little on this piece of steel. When I purchased the coolant, LiveTools sent me some WNMG inserts to try out. Big shout out to Arthur and the team at LiveTools. I'll definitely give them a go. Well, I have to say, I'll be buying a pack of these. Quick test fit and it's looking good. Next I need to tap the bottom hole with a 16mm thread to match the drawbar. It's only 5mm deep, but it will provide a means to capture a knob used to lock the arbor in place. Now the holder is finished machined, I can make the lower part of the mounting frame. This will bolt to the top plate and the holder and allow me to mount the stand and the vise in either the vertical or horizontal positions. The holder is finished with a location bolt into the bottom plate of the mounting frame. The holder is held in the mounting frame top plate by four 6mm socket head camp screws. I'll use the DRO to locate the holes. The pitch circle diameter is 79mm. There are 4 holes, the starting angle is 45 degrees and the end angle is 45 degrees. I'll drill right through with a 5mm drill for the tapping size, then drill the holder with a 6mm and 10mm drills for the cap screws, and of course the obligatory chamfers all round. I can now remove the holder and tap the mounting holes. With the holder located in the frame, I can machine the slots for the 16mm drive dogs. I'll take the sharp edges off with a hand file. The two drive dogs are made from a piece of 16mm key steel cut to 20mm long. I'd like to give the frame a black oxide finish, but first I want to rough up the surface with a 40 grit sanding disc. This will give more consistency to the appearance and provide some resilience for the part that will be held in the vise. I did the black oxide treatment off camera. It did take some time with several applications to achieve the finish. I also treated the tool holder, but the finish was inconsistent and I didn't like it. 4140 doesn't seem to take up the treatment as well as mild steel, and anyway I like the contrast between the treated and untreated parts. Now for the retaining knob. I have a piece of aluminium bar stock that's 45mm in diameter. I would like to make a 40mm diameter knob, as that's about the largest diameter I can knurl with the pinch knurl that I have. A larger, stronger knurl would be nice, but I don't have one. Could be a future project in that. From the knurling tables, I need a diameter of 40.04mm. If I overshoot, the next size down will be 39.65. For a target of 40.04, I got 40.065. After a rough start, the knurl has settled and is producing a good imprint. I'm running the lathe at 40 RPM, as this is a relatively large diameter knurl. I would have preferred a coarser pattern, but I only have a coarser pair of knurls and a push tool, and I don't want to use that. The next step is to bring the threaded part of the knob to 16mm ready for the tailstock die holder to cut the thread. An application of lubricant and a single run at 40 RPM produces the thread. I prefer a die holder with a handheld Tommy bar rather than those with a captured bolt running in a slot. The Tommy bar provides tactile feedback as to how much cutting pressure has been applied, a feature missing on other types of die holders. The final part is to cut a waste in the thread to allow the tool holder to capture the knob before parting it off and cleaning up the end. The tool holder is now complete. The black oxide treatment looks good. The captured knob is of the correct length to allow the arbor to fully seat inside the holder without contacting the top of the threads on the knob. Tightening the knob, the arbor is held firmly in place to make changing inserts easy. Even the large fly cutter can be held to allow tooling changes and easy inversion of the plate. Tooling can now be placed on the bench insert down, making the tools less prone to damage of the cutting edges. I may even relocate the lathe tool post trees to this bench. Well, that's it for this project. As always, thanks for watching. If you liked this video and enjoyed the build, please consider subscribing and giving it the thumbs up. Also, leave a comment if you like. I do read all the comments and reply where I can. Be productive, be creative, but most importantly, be safe in your shed. I'll catch you next time.